Hey, well, good morning, everyone. This side it is Ratan Kar, and today let us look at the second concept on vectors. It's not concept; it is basically a misconception. Okay, so in yesterday's video, we observed something. Let me just go back and see what we have seen. We have seen just a moment. Let me see. We could take it back. Yeah, we have seen about addition of vectors. The misconception that you observe here, when you look at something like, okay, when you look at something like, you want to find out the acceleration of a particle which is moving with uniform speed, but often changing its direction, then usually in such cases, the circular motion, they consider the velocity to be the average, the acceleration to be equal to 0, because speed is uniform, and they just consider that a equal to v minus u divided by t, and as a result of it, they put this as equal to 0. So which was incorrect. That's what we have learned so far. Let me go back to today's problem. So today's problem is not about acceleration, but instead, it's the moment. Instead, oh my God, where is it? It's not connected. Yeah. Okay. So it's about understanding about resultant and relative. What do these terms actually mean? Okay. So this is very, very important to understand it. Most of the students, they forget to find out the distinction between these two terms. And I would like to look at it in detail with an example and see like how does it differ. Now let us consider two cars, car A and car B. Car A and car B. Both of them are moving in the same direction. Let us say one of the car is having a velocity equal to, let us say, 2 meters per second. The other one is having a velocity equal to 5 meters per second. Okay, they are moving uniformly. Now, if I ask you, what is the resultant of these two? Now, first of all, what do you mean by resultant? Physically, it doesn't mean anything to us. Okay, so mathematically, if you say resultant means I am going to add these two vectors, 2 meters per second and 5 meters per second. When I add these two, this will become 2 plus 5, which is equal to 7 meters per second. This is what you call it as resultant velocity of these two. Now, let us say, for example, if the two objects, if the two cars are moving in the opposite direction, then the resultant you will be subtracting it. Anyway, let me not look into this. Now, let us just consider this. Now, I hope you would have understood about the resultant vector. What is the resultant vector? If they are moving in the same direction, you can say this. Now, let us look at the next term known as the relative vector. Okay, relative. Now, with respect to a ground observer, we have a ground observer. With respect to him, you observe the velocity of A is 2 meters per second, velocity of B is 5 meters per second. But with respect to A, how is the car moving? If you ask that question, definitely car is moving faster. That's what is the answer. But if you ask me, what is the velocity of B with respect to A, with relative to A, if I ask you that question, in that case, you can say, see, this is already moving at 2 meters per second. If this was also moving at 2 meters per second, then might be the distance between these two would have been a constant. Since this is moving at much more faster speed, then definitely with respect to A, I would have said that maybe B is moving at a speed of 3 meters per second. In other words, the way how we write is, we can say velocity of B with respect to A. See, first I'll write the velocity of the particle with respect to A is equal to 3 meters per second. Now let me ask the reverse question. Now I am sitting at B and I'm asking you, what is the velocity of A relative to B? Then what is the velocity of A relative to B? Now, before answering this question, let us see what did we do here. Now I got the answer as 3. How did I get the answer 3? I did something like 5 minus 3 is equal, 5 minus 2, 5 minus 2 is equal to 3. That's what I got. Or if I write down the velocity with respect to ground, I can now say this should be VB minus VA. Now what was the question? Velocity of B with respect to A. Okay, which should be velocity of B minus velocity of A. Now let us apply the same logic. See, I have written BA, see here, VB minus VA. Now, using the same logic here, I can now say VAB is equal to VA minus VB, right? So therefore, if I substitute the values, now what is VA? 2 and VB value is 5, which is equal to minus 3 meter per second, right? Which means what does it tell you? It tells you that according to B, A is not following it, but A is moving backwards to it, right? Because he will be moving faster and faster away, and according to B, A appears to be moving backwards with a velocity equal to 3 meter per second, right? So therefore, this is what you call it as relative velocity. This is something which has been learned in your classes already. Okay, but now actually let us go to this problem. Now this problem, I had asked this problem in a large number of entrance. I have seen this problem appearing in many entrance tests and so on. Now let us look at this. Okay, two objects X and Y are moving away from the point P. There is one object Y which is going like this, another object X which is going like this. Let me write down. This is X, this is Y. Okay, the velocity vectors of the two objects are also shown. Which of the velocity vectors in figure 1.38? This is your figure 1.38. Don't ask me where is figure 1.37. वो तो इधर नहीं है, कॉपी कर दिया है बुक से, ठीक है? Okay, best represents the velocity of object X. Best represents the velocity of object X relative to Y. Okay, the moment this question was asked, most of the students, what they do is, hey, there is an X vector here, there is a Y vector here. The resultant of these two, I can write it like this, and this is the answer they write. Though the previous concept was quite easier to understand, but still they mentioned this is your answer, which is totally incorrect. Now, going back to the previous concept, what do we mean by object X relative to object Y? Object X, okay, what is the velocity of object X related to object Y? That's what I mean. So what should I do now? I should write this as Vx minus Vy, right? Now what is Vx? Vx I'll just write like this. I'll write Vx like this. Vy. Vy is this direction. What should be minus Vy? Minus Vy should be like this. Minus Vy is like this. Correct? Vx minus Vy. See this Vx minus Vy, I can write like Vx plus of minus Vy. Because I have to add, So subtraction of vectors means it is addition of one vector with a negative vector of another one. So therefore, I am going to add these two. When I add these two, resultant of these two will be like this. So somewhere you see, I spoke about relative, and suddenly I changed my term to resultant also, right? Only thing is, the difference between these two is that relative refers to one of the vectors in the playground. Okay, where is the playground? There are two vectors in this playground. Okay, so therefore, whenever I talk about a relative vector is with respect to these two players only. Okay, when I do not talk about relative, then I have a person who is standing outside here. Okay, who is away from the system. He is not sitting here, nor he is sitting here. Then you ask me what is the velocity, what is the resultant. Then I can use the sum of the two vectors using the law of vector addition. Now, coming back to the problem. Now you have Vx and minus Vy, and this is your Vx minus Vy vector. So which is the right one here? The right one here would be answer B. Okay, so the student response was A. Now the correct one should have been answer B. Hope you like this video. So these kinds of problems are extremely important from the conceptual point of view. With this, let me stop for today. In the next video, once again, let us understand more about vectors. And there, I'm going to ask you a question now itself. Think about it. There are many vector quantities you have learned. If I ask you what is the difference between a vector and a scalar, you'll always say vector has a direction and a magnitude, while a scalar has only magnitude, right? And if I ask you an example for a vector, you will say velocity, acceleration, displacement, while scalar is only about magnitude like mass, time, and so on, right? But the definition of vector is still incorrect. Okay, let me ask you this question. For tomorrow, you will watch this video. And the question here is that, is current, an electric current, is it a vector? Obviously, right? Everyone thinks it should be a vector because you see, a vector, as you said, it should be indicated by a direction and it should also have a magnitude. Whenever I write an electric current in a circuit, what do? I say 10 amperes, the current moves from the positive terminal to the negative terminal, indicated by an arrow. A current without an arrow is meaningless, correct? So therefore, we should say it's a vector. Now, let me keep this suspense for a while and then discuss whether it is really a vector or a scalar. By now, you would have already guessed the current should have been a scalar. Otherwise, why should I unnecessarily say this, correct? So therefore, anything that has a direction does not indicate it's a vector. Okay, so therefore, let us wait for some time until tomorrow, and then we will have a discussion on this. Thank you, friends, for watching this video. Like, comment, and share if you like this video. Thank you.